Okay, everybody, this is reviewing the test to see what questions you have and so forth. I'm going to just buzz through this as quickly as possible. The answers for sometimes, always, never are sometimes, always, never, always, sometimes. You'll notice D and E. I'm going to talk about those briefly. They were the ones most commonly missed. They have the same drawing. If CD bisects AB, so here's AB, it's being bisected by CD, making these two pieces congruent. It's happening at point M. Then M is the midpoint of AB. That's always true. If AB is being bisected, M must be its midpoint then. If CD bisects AB at point M, so same drawing, CD bisecting AB at point M, then M is the midpoint of CD. Not necessarily. It never says CD is definitely being bisected. So that's a sometimes, because it certainly could be being bisected. We just have no proof of that. Looking at this figure here, everybody did fairly well on these problems. Plane M intersects plane N on this line here, RS. Very few people missed anything on here. The only thing, opposite rays. SR is a ray going this direction, and SK is a ray going this direction. They have to have the same starting point. So they both need to have the endpoint of S continuing in opposite directions. So check your order there. Let's see, a few people had problems with D. P, R, and S, they're all, P, R, and S are all in plane N, so you need to name a point that's not in plane N. K has to be in the same plane as R and S because it's on the same line, so you can't say K here. That's a choice that's not going to work. You need to either say A or T would be your only options to be non-coplanar. 3 points that are non-collinear, that wasn't really a problem. Down here, all the ways to properly name RS. This line, RS, has several names. There's a third point on it, so you can call it RS or SR. You can call it RK or KR. You can call it SK or KS. Those are all of your options, and you need to have the arrows drawn across the top. Continuing down, very few people had problems with number 3. On number 4, here's how you solve it. You know the area of a circle is pi r squared. So if you know the area is 81 pi, and that equals pi r squared, you can solve for r, which is the 9. Then you can dump that into the circumference formula. A couple notes on that. Just leave pi in your answer. Whatever you do with this information after this, pi might get divided out, so you can just leave pi in there. It's a more precise response. Don't drop the pi. A few of you told me that 18 units was the circumference. And lastly, don't forget, if they've told us units, you need to continue to label units throughout the problem and end with units in your answer. Number 5 overall went well for everybody. AB, BC, and AC, you know that AB plus BC is going to equal AC. So you're solving and doing some work with some fractions. A lot of you left it in fraction form, 21/8, which I appreciate. Or some of you showed me the decimal, 2.625. B was a little bit of a problem. You're showing that using your value for x over here, determine if B is the midpoint. So you need to find the length of AB and the length of BC, given you know what x is. So you clearly need to show the value of AB and the value of BC, and you need to give an answer. No, it is not the midpoint because AB does not equal BC. A lot of you just said, no, it's not, and didn't tell me why. Some of you, I saw these calculations, but I didn't know that they were for AB and BC. There was no evidence of that, so I couldn't accept your answer. There was no way for me to tell. There was no way that you justified clearly your answer. Flipping to the back. This first problem went fairly well. You had to find the length of MN given these 2 points, so I labeled them x1, y1, x2, y2, and dumped them into the distance formula. A few of you struggled with the formula. It's the difference in the x's the difference in the x's squared plus the difference in the y's squared. So these should be minuses in between your x coordinates, minus between your y coordinates. This one simplified, minus a negative simplified to plus on both of these. So you end up with the square root of 104. The midpoint formula, however, is the average of the x coordinates and the average of the y coordinates. So there's a plus in between them. You're combining x1 and x2. So it's 9 plus negative 1 all over 2. Negative 4 plus negative 2 over 2. So a lot of you just flip-flopped the operations. When you do that, you get 4, negative 3. Okay. This one down here is an interesting problem because what you have is, you know that RT is the segment you're dealing with. Focus this here. You know RT is the segment you're dealing with. They've given you the coordinates of R and S. So you know that you're starting with the point 2 and X. Okay, you're going to average those two to get 6, your midpoint. And you know you have the coordinate 5 and y, you're going to average those to get 9. So that's what I did. This calculation better equal 6, this calculation better equal 9, and then you can solve for x and y. A few of you are really clever also. You said if s is the midpoint, so you're starting from r. The x coordinate of r is 2, it goes up to 6, so that's a difference of 4. It has to go up 4 more to 10. The y coordinate of 5 goes up 4 to 9. It has to go up 4 more to 13. Okay, so use slope basically to find the differences. The slope is 1, but it goes up 4 and 4. Okay. Next one is a Pythagorean theorem problem. Everybody did fairly well on this one. Your sides are 7 and 8, so 7 squared plus 8 squared. Realize you have to square these first. You cannot, so a few of you told me it was 15. Because you just took the square right off. You said square and square rooting undo each other, which they do, but not if there's addition between them. Okay, the last one. The last one, everybody did fine on the geometry, but you exploded on the algebra 1, which kind of makes me a little nervous. Okay, if this is the perimeter, and if you want to call this the width, I'm sorry, x plus 2, and call this the length, x minus 6. That doesn't make any sense. It should be the other way around, but it doesn't really matter. You can make this this should be the long side, not the short side, but it's not going to make a difference. The perimeter is 2 of the long sides plus 2 of the short sides, and you need to simplify it. It says simplified on this. Okay, so you lost a point if you didn't bother to simplify from here to here. A couple of you blew up on that simplifying. When you distribute, you have to make sure you distribute to the entire expression. For area, you need to multiply short side times long side. A couple of you, you set this up okay, but then you exploded on the simplification. You have to distribute the x, distribute the positive 2, combine like terms. Lastly, find x if the area is 24 plus x. A couple of you did really well on this. So this is your expression for area. Your area equals 24 plus x. You cannot just pop a squared on there. That squared is on these units. It's 24 plus x, that many units squared. Okay? So just leave it like that. All right, you're solving a quadratic here. So I'm subtracting off 24 and subtracting off x to get 0 on one side. Now I have a quadratic equation set equal to 0. You can solve it by factoring. You can graph it. You can use the quadratic formula to solve for x. That's how you solve a quadratic. Some of you did some extraordinarily creative algebra here, which is rarely rewarded. Okay, so once you factor this, I factored it down to x minus 9 times x plus 4. Set each one equal to 0. That gives me 9 and negative 4. You have to make sure these are legit answers. Can I plug 9 in for x plus 2 and x minus 6 and get real numbers? Well, that's 11 and 3. Those are legit side lengths. Can I plug in negative 4? Negative 4 plus 2 is a negative side length. Not going to work. Negative 4 minus 6 is a negative side length. Not going to work. So x minus 4, I'm sorry, x equals negative 4 is not a legit side length. 9 is the only length of x that's usable.